isothermal.
Okay. Actually, you're not there. Yes, what is Carnot cycle, Adya? So what is this telling you?
The temperature, it comes back to the initial point. It goes from A to B, which is isothermal, B to C, right? And it forms almost parallelogram kind of figure. So it's a closed figure.
It gives us okay. It's not parallelogram, it's a curve basically, but yeah, you can simply say it's a alternate isothermal adiabatic processes which make a cycle. And this Carnot cycle or Carnot engine represent an engine with which we are trying to maximize the work output. What is work output? How much work is done and how much energy is given. So based on that, if you recall, we have talked about yeah.
Sir, here we use minus and not TL. This is for reversible.
It's reversible only.
But this is irreversible NCERT.
No, this is for reversible adiabatic case. NCERT integral is what? T1 to T2. What will be the answer? NCERT minus T2. So A to B, B to C, C to D, and D to A. For all the cases we solve. And then we say net work done is WAB, WBC, WCD, WD, and upon Q net. Then we get some result like this. Eta is 1 minus T2 by T1. We rewrite it as QCD upon T2 plus QAB upon T1. And then this is written as Q by T, alternate Q by T is equal to 0. उसी चीज को फिर हम क्या करते हैं स्मॉल स्टेप्स लेके dq में कन्वर्ट कर देते हैं. If I take q by t every time, whether we take smallest element dq in that temperature and put the integral for this whole cycle. So that becomes integral dq upon t, cyclic integral dq upon t, which is 0. And that gives you ds system. Fine. So basically this ds is known as entropy change. इसी ds को हम क्या नाम देते हैं? This ds is called entropy change. So write down few terms for this. Cyclic integral of ds is equal to cyclic integral of cyclic integral draw करना है but in integral sign we go like this circle. Cyclic integral ds is cyclic integral dq upon t dq upon t, which is equal to 0.
No, what is it?
Okay, so basically this dq upon t, which is coming as ds, is output of this Carnot cycle, which you have understood once you do that. Now, when you say this dq upon t is 0, what is meaning of it? Any property for whose value cyclic integral of property is 0, that is a state function.
Okay.
So, right. Any property for which we can write cyclic integral d property is 0, that is
So what is the cyclic integral? How does it differ from a normal integral?
Normal integral is, let's say you are doing integration, you get the limits, this to this. Cyclic means on the complete area which you have shown there. So this is for the whole area which we have mentioned here, right? So cyclic integral d property is equal to 0. That means this particular property is a state function. So now you know state functions like du is a state, u is a state function. So what is cyclic integral du will be? It will be 0. Likewise, what is cyclic integral ds and dh? They are all 0. Okay. Cyclic integral of dg is how much? That's also 0. So note down. Since all of them are state function, their values are 0. But how about work done? Cyclic integral of work is non-zero because work is not a state function. It is a path function. Because work change कर जाएगा if you change the path, work will change. Is that okay? Just note down this information. All right. So what is the learning for the current discussion? We can say if you can write for any property cyclic integral d property 0, that means that property is a state function. Okay. So if we say cyclic integral du is 0, u is a state function, dh is 0, h is a state function, ds is 0, S is the state function, dg is 0, g is a state function. dw is now 0, that means w is not a state function. Okay, it's a path function. ये समझ में आया? अच्छा, अब एक आगे बढ़ते हैं. So let's do the next discussion, which is on so right now entropy. Write the heading entropy. Entropy is degree of disorderness or degree of randomness or degree of chaos. Degree of disorderness, degree of randomness or degree of chaos. We can minimize because nobody's there, right? So we can minimize that window. No, the first one. First one. Yeah, perfect. Yes, perfect. So, degree of disorderness, degree of randomness, or degree of chaos. What is the meaning of it? See, you observe anything. Let's say, for instance, we take a glass of water and we stir it well, like with some spoon. Let's say we just start moving that water. What will happen? You are going to create more randomness in the still water. Okay, you throw a stone in a stationary pond. What will happen? Waves will be created. Okay, they will move from center to periphery. That means you're creating randomness or disorderness. In simple words, if you introduce anything in nature, that always creates randomness. You do whatever process. Let's say I'm just raising my hand. It's increasing entropy of universe. Whatever you do, it will increase entropy of universe. So all the natural processes will always be irreversible and they will always increase entropy. It's a very valid fact. ठीक है, अब इसने गर्दन हिलाई तो इसने एंट्रोपी बढ़ा दी यूनिवर्स की. You are again doing this, you are increasing the entropy. So whatever you do, you are always increasing, you are adding on entropy of universe. Okay, global warming, climate change, सब क्या है? Entropy of universe is increasing. It is tending to the maximum value, right? Increasing, where there is no limit, right? It will keep on increasing. Is that clear? So that you have to understand. Now, next part. When solids become liquid, then Sanjay, some practice, I think, here.
Music.
Okay. Interhouse. Okay, what is interhouse?
Like we have houses in school.
No, so there is some function going to happen.
No, so we have competitions, inter-house competitions.
Acha.
Yeah. So from music.
Solid to liquid, what will happen? Can we say entropy will increase? Liquid to gas, entropy will increase. Liquid gas to convert gas की एनर्जी ज़्यादा है. Okay.
It's a symbol.
S. Capital S. Gas molecules are increasing, what will happen? Entropy will increase. Okay. Number of gas molecules are increasing, it will increase. You take one molecule and dissociate into more pieces, it will increase the entropy. You take many things, convert into one, you are reducing the entropy. Okay. So when you talk about polymerization, it's decrease in entropy. Now there are two terms that you have to understand very clearly. I'll give an example, just try to understand with that. Okay. Let's take a student comes from his school and then he puts bag in one corner, shoes in other corner, okay, himself or herself in another corner. Okay, so what will happen? The entropy of room will be less or more? More. But what is the entropy of the person? Is he taking any pain?
No.
Is he taking any consideration or any tension to put things in the right place? No. Person aram se chill kar raha hoga, right? So entropy of the person is what? Less. Entropy of the room is high. So room is your system, person is surrounding, or person is a system, room is surrounding. Anyway, you can consider it, right? This is what you have to keep in mind. So when I say polymerization is reducing the entropy of what? System. But corresponding surrounding, it will be other way around. Okay. And system and surrounding becomes universe, which is called delta S universe. So whatever changes there happening in system, plus whatever change is happening in surrounding, put together is called change happening in the universe.
So could you explain when entropy decreases?
Yeah, entropy will decrease in like polymerization. Multiple things are becoming one. So basically, the entropy of that particular system is going to decrease.
So when you are explaining a person's scatters this thing, like
Yeah.
why
So-
is a person will be less?
Okay, why it is less? Now see other way around. A person who is very well organized, right? So he's putting things in the right place. So the room's entropy is less,
Okay.
but the person has to take tension for everything.
Because
He has to arrange things. Shoes मेरे को यहीं पे रखना है, bag मेरे को इधर ही रखना है, मेरे को यहाँ पे बैठना है, right? So you understand? So the person's entropy will be what? Very higher. Rooms will be lesser. So one is compensating other. This is how things proceed, right?
So basically, if system entropy increases, surrounding the entropy decreases.
We can say that. Okay.
So
But
there's no
both
change in the universe's entropy then.
I'm coming to that. That is for reversible process. Because reversible process, the system and surrounding will exactly having same increase and decrease.
Yeah.
And hence cancel out and become zero. And reversible process, you know, is hypothetical process. There is nothing reversible. Reversible process what? It's an ideal hypothetical situation. That is reversible. It's an ideal hypothetical situation. Correct or not? So write down one line. First you complete this and I'll make you write that line. Polymerization is clear. Pressure is increased. क्या चल रहा है भाई यार, क्या हो गया इसको? So pressure you increase. If you increase pressure, temperature will increase. That's one case, right? Other cases, increase the pressure, temperature is constant. That's a case number 2. If temperature is constant, we know that if pressure is increased, volume will reduce. Because P and V are moving in opposite direction, right? So if pressure is increased, temperature is also increasing, then entropy will increase. But if pressure is increased, temperature is constant, volume is decreasing. Now see, you have this vessel. You are increasing pressure. Vessel's volume is lesser now. So the molecules are moving in a smaller volume. Is it? Are they paying attention to this? So this volume is becoming half, let's say. Now they're moving in half of the volume. So what will happen to the entropy? It will be reduced. Both the cases note down. Pressure increase, temperature increase. Pressure increase, temperature constant, volume reduce, entropy will be lesser. Temperature increase, it will increase. Atomicity is higher, entropy is higher. So let's say you have 1 mole of gas NO and 1 mole of gas N2. Provided we have the same atoms. Don't compare N2 with CO2. I'm comparing NNO with NNO, different combination. So NO and N2, if you compare, N2 will be higher because N2 has more number of atoms, right? So more degree of freedoms will be involved. More number of atoms are involved, right? So randomness will be higher. Note down this also. So these are certain points for entropy or disorderness. Any difficulty in this?
The first one, if you go from liquid to solid, entropy will decrease.
Liquid to solid will be decreasing.
So, but noise will anyways come now because it's shared space.
Hmm?
So one noise always comes because the space is shared.
No, you should not shout. Shout like that. You can do work, there's no problem. Does not work. No? We are also doing. My voice will not go outside. So entropy of system plus entropy of surrounding is entropy of universe. Right on this point. Entropy of system plus entropy of surrounding is entropy of universe. So basically, system plus surrounding is universe. Okay. Note on the point one. Entropy of system plus entropy of surrounding is entropy of universe. Change in entropy of system plus change in entropy of surrounding is zero if it is reversible process. Okay. So basically, reversible process, what is going to happen? By default, reversible process does not do any change in entropy of universe. But reversible is hypothetical. It's an ideal situation. So if system is increasing, surrounding will decrease. If system is decreasing, surrounding will increase. Understand? So let's say one is increasing by x value, other will decrease by x value. Or other is decreasing by x value, other will increase by x value. Overall, they will say plus x minus x is 0. Or minus x plus x is 0.
So why is reversible together?
Irreversible. Because reversible processes are not building any kind of entropy. Why it is not building? Because for reversible case, you have proved integral ds system is what? 0. Few minutes back we have discussed, right? That Carnot cycle part. So integral ds system is 0 means what? It's a state function. And for that whole part, if you just move across, it's not changing the universe things, right? Come to the next part. In nature, all processes are irreversible. In nature, all processes are irreversible, and entropy of universe is ever increasing to become maximum.
So what will happen if it reaches maximum?
It will not reach maximum. It is always tending to become maximum. That's why the word is ever increasing. Okay. It's like it's just keep on shooting up. Okay. And in nature, there is nothing reversible. Even if you say it is reversible, it is not correct, right? Everything is irreversible in nature. You can say water cycle is there, you can say nitrogen cycle is there, but these are cycles. They're not reversible process. It's not like the water which will be evaporated in exactly same way it will come back and all. No, it's just a cycle, right? No reversibility is ensured in any process of nature. So just to summarize the whole discussion, in nature, everything is irreversible. Since everything is irreversible, for all the cases, entropy of universe is increasing. If entropy of universe is increasing, it is tending towards the maximum value, right? Any difficulty in that part? Any issues in this? Okay. So, can we say delta system plus delta surrounding is non-zero for natural process or irreversible cases? Or can we also say it is more than 0? Okay. Delta system plus delta surrounding is 0, which is for delta's universe, which is reversible case. So, this is the summary of our discussion.
You can't have entropy negative.
Entropy of system or surrounding?
Anything.
It can be negative, why not?
Like entropy of the universe.
Universe cannot be negative.
It cannot be negative.
Universe cannot be negative, for sure. Universe, the best case scenario is 0.
When
Best case scenario is 0 if it is reversible process.
so that's when maybe like entire universe is at absolute zero, then nothing happens at all. Then
Yes, we can say, see, reversible process, इसको थोड़ा और deeply समझो. Reversible process means what? Everything is having quasi-static.
some movement.
Okay? Infinitesimally slow. So आपने एक बार यहाँ से let's say उसके ऊपर रखा एक m mass रखा dm mass, it's moving very slowly. It's not doing any exchange with surrounding. So in such processes, universe entropy is as it is. It's not changing. That is only reversible process. So ये पूरी बात पर समझ में आनी चाहिए. First result clear, then we can proceed further. So now if it is clear, let's come back and write case by case करेंगे, solve करेंगे questions and try to understand. Write on the first question. 1 mole of an ideal gas is expanded isothermally. 1 mole of ideal gas is expanded. I just get what? Isothermally.
Is that same question? Just came the.
करिए सॉल्व करने की कोशिश करिए.
So if processes.
If processes reversible, second is irreversible. 2 questions है. अब फॉर्मूला आपको सारे पता है. How do you get delta system? So you know ds is dq by d. ds is dq by d for reversible case. dq मेरे को पता है आइसोथर्मल का कितना होता है. नहीं dq no होता है, du 0 होता है. du is dq plus dw. dq is minus dw. And minus dw is 3dp. Because dw is minus pdp. और p का वैल्यू कितना है? Minus nRT upon v. If you talk about ideal gas. So रखो और solve करो. बताओ delta system का फॉर्मूला क्या है?
Formula for S.
ds is dq upon d.
Or
Right? ds is dq upon d. dq की वैल्यू वहां से रखो.
Reversible.
Reversible. dq is how much? du plus pdv. du तो 0 हो गया. So pdv upon p is how much? Per ideal gas. nRT by v.
Can't I use D find the work done?
It's okay.
So then you integrate.
P is nRT capital letter. T capital letter. And see, this is upon v, no? So this whole thing upon v. This side you have done upon v. This side also you should upon v, no? The whole thing. Or you say just this is dq. Just cut t here. dq is du plus v.
Yeah, that's why that.
Integral. This is what you notice ds. This is ds. Now get delta s. Integrate both sides. कितना आ रहा है?
10 no, wait, 10.
Give your answer in terms of R. R ln 10. Good. This is what delta s.
Just
So right, delta system is R ln 10.
the surrounding is minus 10.
Minus R ln 10.
Because the surrounding is 0 for the reversible.
dq का वैल्यू सब्स्टिट्यूट करो को t से t कैंसिल हो जाएगा. dq upon t में जो upon t और ऊपर जो t था वो कैंसिल हो जाएगा. So your formula should come nr ln v2 by v. बना ऐसा फॉर्मूला आ रहा हो इंटीग्रेट करके.
Sir,
Yeah.
but is it possible S equals U by T?
ds is dq by t. That's for reversible case only. You can apply this.
For irreversible,
You can't apply this.
that's what it is.
Think.
Sir, minus ln
Huh?
minus ln.
For system.
Yes,
Why minus and system?
Plus.
minus
DS is DQ. DQ is how much? DQ is
this is something
PDQ. तो minus sign यहाँ पे कैसे आ गया?
because P is minus NRT.
नहीं, P is not minus NRT. P is NRT by V.
Oh,
और R is छोटा कहाँ से आ रहा है? R तो universal gas constant होगा. R capital करो. R capital. Awesome. R पहले लिख लो. So ln10 R में ना वो ऐसा लग रहा है R उसके अंदर चला गया. Or you put a bracket ln10 then bracket and then keep R outside. You getting the same answer? No? Sure. What you've done? dq is minus dw, dw is minus pdv. So you put what is dq? अच्छा dw is all credit
right.
dq is minus dw, so यहाँ पे plus pdv हो जाएगा. dw is minus pdv. Minus or minus pdv is what? Plus pdv. So dq is what? nRT by pdv. ds is what?
Okay,
dq by t.
Minus this value.
ds निकाला फिर. So this upon t, t cancel हो जाएगा. So बचा क्या? nr dv upon v. nr dv upon v का integral nr ln v2 by v2. Complete. Complete and show. Go to irreversible case. Cut it, right on the next page, no problem. R ln10 is delta S system. What is delta S surrounding? Minus R ln10. What is delta S universe? 0. So पहला आप देख लो solution. आपने ऐसे लिखा ds is dq reversible upon t, dq reversible is du plus pdv upon t. pdv को लिख दिया आपने nRT upon v. Just see. Integrate किया integral ds system is this formula. ये formula नोट कर लीजिए. Directly use कर सकते हैं. Delta S system is nr ln v2 by v1. किसके लिए valid है formula? Isothermal reversible case. ठीक है? Direct formula is valid. If you see the Q value, it was nRT ln v2 by v. Check your answer because that was t times that number, right? ln 9 by delta.
For the second dice with them.
ln Q1.
For irreversible.
Or no, ln won't come actually because you don't integrate.
Now see the next part. Minus delta surrounding was delta system, delta surrounding of minus nr ln v2 by v1. Delta universe comes 0. First part is clear. Everybody. पहले यहाँ तक confirm हो गया. कोई problem नहीं होता है. Any issues? Any problem? Any difficulty? No issues? अब irreversible try करो. सोचो कैसे निकाल सकते हो. शाम समझ में है? आद्य, everybody clear? चलिए second part की तरफ बढ़ते हैं. Try to answer second part of it. एक बात बताओ. In reversible case, what is the starting point? What pressure and what temperature? What volume? Temperature is 0, correct. But what was the initial pressure?
10.
Okay. What is the final pressure?
1.
In irreversible case, what is the initial pressure?
10.
What is the final pressure?
1.
In irreversible, what is temperature change? Irreversible.
0.
0. Same temperature. Initial, final temperatures are same. So what will happen to volume? Pressure is same. Temperature. Initial and final. Whatever initial volume was there. No, whatever initial volume was there for reversible,
Yeah. Oh, volume increase.
and you're going to irreversible. Whatever is the volume and reversible, same will be the volume for irreversible also. Value violates P same, T same, so we will the same over. Top and bottom we will not match. I'm not telling that. I'm saying that reversible starting point, irreversible starting point are same. Reversible endpoint, irreversible endpoint are also same. Do you agree with this? And this property, delta system is a state function. So देखिए, delta system is a state function. If it is a state function, does it matter that you go from reversible route or irreversible route?
No.
So what is the answer?
Same.
So delta system will be same. लिख लो. Delta system is a state function. Just see this, what I've written. Write like this. Delta system is a state function. You are starting from 10, 300 to 1, 300 in both the situations, be it reversible, be it irreversible. So since my endpoints are same, my delta system will be same. Since it is a state function. समझ में आ रही बात है? बहुत बेसिक सी बात है, कर लोगे इतना? तो आंसर क्या होगा फर्स्ट पार्ट का? RLN10. No second thought. Delta system is NRLN V2 by V1. ये फॉर्मूला लग जाएगा. N is 1, R is R, ln V2 by V1 is P1 by P2, P1 by P2 is 10 by 1. So answer is RLN10. सीधे सीधे कर लोगे. ये समझ में आता है V2 by V1 is P1 by P2. Because P1 by P1 is P2 by 2. Because T is constant. I hope this part is clear. अच्छा जी. What is delta S surrounding? Now this is interesting. So right now, delta S surrounding is written with minus Q irreversible upon temperature. Note. Delta surrounding is minus Q irreversible upon temperature. Minus Q irreversible upon temperature. Where Q irreversible indicate heat exchange with the surrounding. Q irreversible indicates heat exchange with the surrounding. अब आपको मैंने फॉर्मूला दे दिया, यहां से आप खुद सॉल्व कर सकते हो. बोलो डेल्टा यू क्यू प्लस डब्ल्यू. अच्छा जी, डेल्टा यू खुद कितना है? हाउ मच इज डेल्टा यू? 0. तो क्यू कितना हो जाएगा?
माइनस
डब्ल्यू. सो माइनस क्यू क्या हो जाएगा?
डब्ल्यू.
डब्ल्यू. और डब्ल्यू का वैल्यू कितना है रिवर्सिबल केस में? हाउ मच इज डब्ल्यू?
minus RC and
नहीं भाई, इरिवर्सिबल आइसोथर्मल चेक करो.
And then minus.
minus NRT and then
माइनस पी एक्सटर्नल V2 minus V1 is the work done.
1 minus 1 by
Minus
P.
P external V2 minus V1 is the work done. So P external V2 minus V1 is the minus work done.
Yeah.
That value you can put, right? Solve the numbers.
minus NRT and then 9 by 10.
LN कहाँ से आ रहा है? अभी LN कहाँ? फिर मैं बोल रहा हूँ LN क्यों आ रहा है?
So here,
इसमें LN कहाँ है बेटा? क्या बोल रहे हो?
sorry, so 9 by 10
9 by 10 R. प्लस है ना माइनस है?
plus
फिर से सोचो.
minus
माइनस Q irreversible upon T. Minus Q irreversible upon T. Pressure is becoming 10 to 1. Pressure 10 से 1 हो रहा तो क्या हुआ ये केस? Expansion का केस हुआ ना?
Compression.
So do it. सीधे कैसे लिख दिया आपने? लिखो तो यूज करा. हाँ? Right here, no? What do you know? I also want to see. मन में कर लेता आधी चीजें. Is for?
irreversible.
So this is whose formula? This is for?
But this is the work done in irreversible case. Isothermal.
So upon PV one.
And for S.
P external is P2.
P external can be taken as P2.
So that's 1. And V2 minus V1. It's 10 minus 1 because you take ratio of
No, that is pressure. It's not
You
volume.
have to put minus.
We have to put V is nRT by P. करो solve करो. So you can say delta U is Q plus W. You see, minus Q upon T is W upon T. W is minus external V2 minus V upon T, right? Values हो जाएंगी सारी. Then you'll put the numbers. P external is P2. इसको note कर लीजिए पूरा एक बार. And V2 is nRT upon P2. V1 is nRT upon P1. Upon T में सारे T cancel हो जाएंगे. NR बाहर चला जाएगा. N का value 1 given है. R है. अब values रख लीजिए. Try to simplify the whole thing. P2 is 1. So P2 upon P2 is 1. Minus P2 upon P1 is 1 by 10. So 1 minus 1 by 10 is 9 by 10. R is the 9 by 10 R. Check करके देखो सारी values. This number, if you solve, you should get this, which is this, which is this. Please confirm. हो गया? Complete कर लीजिए. Complete. Okay. कर पाएंगे. कोई भी प्रॉब्लम यहाँ तक तो बताइए. नो प्रॉब्लम. कितना सॉल्व है पूरा क्वेश्चन? रिवर्सिबल, इरिवर्सिबल, नो डाउट. वेरी गुड. चलो अभी समझ में आ गया तो एक आगे बढ़ते हैं. वन स्टेप अहेड. सॉल्व. Delta surrounding is defined as minus heat exchange from surrounding upon temperature. So this again comes from other relations in thermodynamics. So we can use that direct formula. Delta surrounding minus Q exchange with surrounding upon T.
The bodies are only for actual thermal.
No, this minus Q exchange upon T is for everywhere. But the front one is like will change.
This
Case
is
by
only
case.
for
Yes, it will change case by case. So try to answer this question.
so we can use formula for what reversible is.
So the standard formula is TS system is dq upon T. That is always visible. And the standard formula is delta surrounding is minus Q irreversible upon T. That can always be used in all the cases. So try to use it.
Then why do they specify non-linear chat?
Gamma is 4 by 3. I gave you gamma directly 4 by 3. But it's a non-linear thing. It will have radio freedom, translational 3, rotational 3. You've done right?
Yeah.
And vibrational will be 3 and minus 6. But vibration is non-active, so only 6 will be considered. And gamma is 1 plus 2 by n. F is 6, so 1 plus 2 by 6 is 4 by 3. I gave you directly gamma is 4 by 3. Gamma is also called Poisson's ratio. It's called Poisson's ratio. Why are you applying formula?
Find final temperature.
And why are you doing that?
Because
Isn't temperature constant?
No.
I know. It's just zero.
एडियाबैटिक
I just
क्यू जीरो है तो सॉल्व क्या कर रहे हो आप लोग एडियाबैटिक का क्यू कितना होता है जीरो तो डी क्यू अपॉन टी क्या होगा जीरो अपॉन टी जीरो अपॉन टी का इंटीग्रल क्या होगा जीरो कुछ सॉल्व भी नहीं करना है इसमें सो रिवर्सिबल केस डेल्टा सिस्टम इज जीरो डेल्टा सराउंडिंग इज जीरो डेल्टा इज यूनिवर्स इज जीरो सो पहला तो ऐसे सॉल्व किया
So for all
irreversible.
huh? For all identified, they get like that.
For reversible part, all three are zero. Zero, zero, and zero. Yes or no? Why surrounding zero? Because it's not exchanging heat from surrounding. Adiabatic is a cutoff, no? So surrounding से तो exchange हो ही नहीं सकता. So zero हो जाएगा. So delta system is zero because dq is zero. dq upon t is your formula, no? dq itself is zero. The integral of dq upon t क्या होगा? Zero ही होगा ना? ये भाई लगा हुआ बिल्कुल सॉल्व कर देगा सब कुछ तो. So note down delta system is zero, delta surrounding is zero, delta universe is zero. नहीं तीनों नहीं से होगा लिखो पर लिखो लिखो प्लीज राइट डाउन बाहर अरे अभी अंडरस्टूड है 2 महीने बाद ये सब अंडरस्टूड से अंडरगॉन हो जाएगा लिखो लिखने में बहुत आप लोग पेन लेते हो देखो इसकी फॉर्मूला बनने में
Everything is there.
yeah everything is there that is a good formula no all formula you can revise
Like not just formula.
and the questions are also there
Yeah.
okay good चलो irreversible case solve करो
Sure, but delta Q is just zero, right?
हाँ but मेरा formula क्या ds irreversible is can I use ds irreversible as dq upon t no I can't that is only valid for ds system is dq reversible upon t it cannot be dq reversible upon t now in the previous case it was same because our pressure and temperature conditions were same is this same this time also is the temperature of reversible same as reversible are you reaching to the same end condition answer is no
Now you need to calculate that.
हाँ अब कैलकुलेट करना होगा नहीं वो वाला नहीं वो नहीं चलेगा बिकॉज वो रिवर्सिबल का है
P to the power 1 minus gamma.
वो नहीं चलेगा दैट इज फॉर रिवर्सिबल द अदर वन व्हिच इज फॉर इरिवर्सिबल
T times. Is temperature.
सॉल्व कर ले भाई सॉल्व करके दिखाओ
Minus P external.
minus p external v2 minus v1 is ncv t2 minus t1 then we put t1 t2 is not known v2 minus v1 is nrt2 upon p nrt2 upon p2 nrt1 upon p1 all these values we put simplify that and solve that equation get temperature No, solve.
So T minus T1 by gamma minus 1.
It's the same.
Solve.
The same value.
Solve.
So 16,300.
Solve.
That's a form. That's T2 minus T1 by gamma minus.
Huh?
T2 minus T1 by gamma minus.
We simplify. You can always simplify. The formula is NCV T2 minus T1 is minus K external V2 minus T1.
First the same value.
हाँ तो एक बार सॉल्व करो यार क्या क्या है एक बार और सॉल्व कर लो प्रैक्टिस चाहिए थोड़ी आपको कोई आ रहा है उधर से
So you know that wall is about to fall down, like
Yeah.
the other room, the big one, before like that door thing, the entire thing is shaking. Like it's loose from top. Like the AC vent also
Yeah.
fell down.
Yeah, then they put it back.
Aditya closed the door. Normally only, not even had it fell. Then we tried putting it back and then
करी
For 230.
repeat it good इतना ही करना है
that's what you're finding.
That
Oh,
You're finding.
T2 ही निकालना है once you get T2 you will know the end condition फिर क्या करना मैं बताता हूँ पहले आप T2 मत मानिए
Oh, I don't know what to do.
no if you can try but
Is that a formula?
no we will derive a formula sorry कैसे पता है इतना ही होगा सॉल्व सॉल्व करो T2 बहुत शॉर्ट शब्द है भाई बच्चों
This one also go there.
ये शक्तियाँ आपके पास ही है दिव्य शक्तियाँ अलौकिक शक्तियाँ इतनी दूर का सोचना बड़ा मुश्किल है कुछ तो गड़बड़ कर दिया माइनस कैसे आ गया हम
Well, this is minus of
हाँ ठीक है नाइन मिनट ऑन दिस कुछ गड़बड़ है हाँ नॉट दिस वन that is 300 or 800
300 by 60. Yes. 9, 18. 9, 5, 4.
So,
first everyone reach to that level
So 2 to 9 point something. So you round down.
so see the first case एक बार मैं रिवाइज कर देता हूँ रिवर्सिबल केस DQ0 DQ upon T0 DS system is DQ upon T0 डेल्टा रिवर्सिबल हो गया सॉल्व कोई प्रॉब्लम्स क्लियर इरिवर्सिबल में आ जाओ DS system is not equal to DQ irreversible upon T you should be very clear about it ऐसा कोई फॉर्मूला नहीं so end points of reversible and irreversible are not same लिख लो उसको नोट करो your end points are what 16 atmosphere 300 Kelvin, you are going to 1 atmosphere 230 Kelvin if it is reversible. You are going to 150 Kelvin. If it is irreversible, going to 230 Kelvin, right? अभी हमने 230 solve किया है. Reversible करते तो कितना आंसर आता 150 Kelvin. Remember? So your endpoints are not same. If your endpoints was same, then my answer would have been same. If you go to 150 Kelvin, your answer would have been 0. Reversible case.
When you calculate
If you calculate the reversible case,
That
you
got
that this formula. You give 150, then answer would have been same as in 0. Delta system should have been matched, but it was not same condition. Hence, we cannot say that our delta system will match. So the question is, what is not matching, what we can do? So answer is, you have to solve with any general process. अब general process क्या होता है? General process is we have to use something which is not limited to just adiabatic condition, which is one place to other place via any reversible process. How can we calculate the value of what do you call ds? Okay, so write down ds is ये जनरल फॉर्म है सबके लिए वैलिड. ओके, कोई स्पेसिफिक चीज के लिए नहीं, सभी के लिए वैलिड है. राइट डाउन ds is, and please note down, and please write down this part also. ds system is not equal to dq reversible upon d. Write down end point of reversible reversal are not same. Write down what are the end points of reversible, what are the end points of reversible. नोट कर लो सारी चीजें प्लीज. ठीक है, फटाफट नोट कर लो. देन एक ब्रेक ले लो, फिर इसको उसके ब्रेक के बाद ही करते हैं आराम से. फर्स्ट इसको कंप्लीट कर लो, यहाँ तक सभी लोग नोट करो, देन टेक अ ब्रेक, देन विल स्टार्ट फ्रॉम हियर. यहाँ तक कर लो. ओके,
So it's actually the same formula, just written differently.
it's the same formula, but now this time I can't use dq 0. I can't say du is 0.
Like PQ is DU plus PDV.
Correct. And then we will try to integrate this as a general form.
So how do we get 150?
With that t power gamma p power 1 minus gamma constant. That is reversible applicable, right?
We
So
don't
reverse-
like that though, right?
Yeah, we remember, we can find out and check, but those numbers will not match. That is 150, this is 230. So now you know already that in isothermal case, endpoints meet, endpoints match. But in this case, endpoints will not match. So your answer cannot be applied directly. Clear? Break let me see this point, then start. You can just keep the video and audio off. कर देगा.
So why are you unmuting if there's no one there?
Record the recording.
They can watch recording. Okay. So right now ds is dq upon d. And dq is du plus pt. अब dq du plus pdv क्यों होता है? Because dq plus dw is du and dw is minus pdv. Correct? सोच कर देखो. तो du is dq plus dw, dw is minus pdv, तो minus pdv आपको उधर चला जाएगा. That will become du plus pdv. Upon t कर दोगे आप. ठीक है? So du is ncv dt plus p is nRT by v dv upon t. हो गया? So ds becomes ncv dt plus nRT dv upon v upon t. Now, in this whole discussion, have I used anything specific? कुछ भी specific use किया मैंने अभी तक? सारा generally, it's all general discussion. अच्छा जी. इसको integrate करके देखो value क्या आएगी? What will be the numbers? Integrate ds.
So which one? This.
Yeah. Yeah, this integrate ds will be integration of this, integration of this. So what will be the value coming up? Check.
So it will become T2 minus T1 and B2 minus.
NCV dt upon t
And it should be
and then nRT
You get
dt cancel nR dv upon v. Two integration.
and then T2 by T1
Yes.
and
Second term will be NR ln v2 by v1.
Yes, nR ln v2 by v1. So integration become NCV ln v2 by v1 plus nR ln v2 by v1. अब एक और चीज बताओ, यहाँ तक कुछ भी मैंने स्पेसिफिक किसी की बात की है? इट्स अ जनरल थिंग. एक फर्स्ट लॉ यूज किया. फर्स्ट लॉ मतलब dq is dv dv is फर्स्ट लॉ. थर्मोडायनामिक्स यूज किया, वैल्यूज रख दी, इंटीग्रेट कर दिया. देयर इज नथिंग रॉन्ग.
the first law, delta u equals
Yeah.
u plus w.
Yeah, dq is dv. Okay. Now any difficult in this? So integration will come like this. We solve the whole thing. Just see, check your results. यहाँ तक पहुंच जाओ पहले सभी लोग. ठीक है. अच्छा जी. CV का वैल्यू कितना है? 3R. Why CV is 3R? R upon gamma minus 1. Gamma is 4 by 3. 4 by 3 minus 1 is 1 by 3. 1 by 3 का 3 ऊपर जम करके जाएगा 3R बन जाए. लिख के देख. CV is R upon gamma minus 1 is right. CV is R upon gamma minus 1. So एक बार आप सॉल्व करेंगे तो CV का वैल्यू 3R आता है कि नहीं? चेक. Gamma is 4 by 3. 4 by 3 minus 1 is 1 by 3. 3R हो जाएगा हमारी. अच्छा जी, यहाँ तो समझ में आ गया. अब मेरे को एक चीज बताइए. Delta S which we have got is applicable for all general cases. If the case is isothermal, what will happen? T1 and T2 will be
what?
T1 upon T2 is 1
Why?
or T1 T2 is same. So what is ln of T1 T2 upon T1?
0.
So what is the first term becoming here?
0.
So what is the formula coming up?
NR ln v2 by v1.
यही तो use किया था isothermal में. Check your formula.
Yeah.
Which you have used.
Yeah.
NR ln v2 by v1. If the same thing is isochoric, isochoric means second one becomes 0. So what is the formula?
NCV ln v2.
Note कर लीजिए, लिख लीजिए. In case of isothermal, T2 will be equal to T1. First term becomes 0. Formula becomes delta S. Isothermal is nR ln v2 by v1.
Volume 0.
Yeah, volume is not changing. Volume is not changing. Chinmay, Niharika, Sanjay, can you hear me? All three of you?
Yes, sir.
All right. So we are left with certain things in ionic. What is the purpose of titration? Why do we need titration? I'll put it that. Sham.
Whatever that acid is. Then yeah, so
Okay. Anyone from online? Niharika, Chinmay?
Sir, it's to know the concentration of of a solution.
So basically, I'll put in very simple word. Knowing unknown with the help of known. कैसी लगी definition है? With the help of known. इतनी सी बात है. So knowing unknown with the help of known means what? Let's say you're talking about any titration for that matter. So titration can be of three types. Please write down. Titration can be of three variety. It can be acid-base titration. It can be back titration. It can be redox titration. Okay. These are three types of titration that you come across. Acid-base titration, back titration, and redox titration. So when you talk about acid-base titration, let's say you're titrating some known acid and there is some unknown base and you want to calculate the value of its concentration. This is known, this I want to calculate, or vice versa. Base is known, acid is unknown. That is called acid-base titration. What is back titration? Back titration is basically you are doing certain reaction. Something is remaining. Now you are just titrating it back. Let's say you take some acid A1, react with some base B1. A1 remains. It required some other base B2. Right? This is back titration. So you'll say B2's gram equivalent will be same as A1 remaining gram equivalent. B1 gram equivalent plus B2 gram equivalent put together will be A1 gram equivalents, right? That's how we do the calculation part. So the titration part is governed by a term called gram equivalent. Please write down this word. Gram equivalent. होता क्या है gram equivalent से? Gram equivalent is moles into n factor. It is defined as moles into n factor. अब moles क्या होता है आपको पता है? Everybody knows about moles. What is moles? Moles for any atom is weighed by atomic weight, weighed by molecular weight for molecule, weighed by ionic weight for ions. N factor क्या होता है? For acid, N factor is number of H plus it donates. For base, N factor is number of OH minus it donates. For salt, N factor is total positive or total negative charges it is carrying. Right? N factor is that number. I hope HCl N factor कितना होगा? 1. H2SO4 N factor कितना होगा? 2. ये basic आपको पता होंगे सभी. Right? Any difficulty? Please note down this also. So you multiply moles into this, you will get N factor into moles. This will be gram equivalents. And gram equivalents of two reacting things are always same. Just write on the slide. Gram equivalents of two completely reacting substances are same or equal. ये basically rule है, ठीक है? Gram, इसका नाम ही है gram equivalent. The quantity which is equal for two different things. ठीक है? Is that okay? So gram equivalent is same for two reactant substances. A, B से reaction करेगा तो दोनों के gram equivalent क्या होंगे? Same ही होंगे. Any problem in this part? Okay. A and B reacting, so gram equivalents क्या होंगे? Same होंगे. So you're reacting A1 plus B1, giving A1 remaining. ऐसा केस बनता तो क्या बोलोगे आप? Remaining A1 requires B2. Okay. Initially, reacting A1 is equal to B1. अब सोचो B1 B2 together लेके आ जाओ तो क्या हो? Total A के बराबर हो जाए. Is that okay? Third thing can be redox. Redox is what? Reduction oxidation cases. So in this, what is happening? You will have some oxidizing agent, or you may have some reducing agent, Oxidizing agent will be reacting with some oxidizable material or oxidizable material. See, everything cannot be oxidized, no? So you should have something which can be oxidized. अभी आप सोचो copper +2 को लेके आ गए आप बोले oxidize करो इसको. You can't do anything with this. It's already in the highest state. There's no copper +3, there's no copper +4, there's no copper +5 that you can form. So it's like a person standing on top floor of building. You're asking him to go up. Okay. So only way is to go down and to go. Can't go up. Is that clear? So there's no option of going up because it's already on the top. Is that clear? So oxidizable material is required for oxidizing agent, and similarly reducible material is required for reducing agent. कर लोगे? ये पूरी बात समझ में आ रही? So what is titration? Titration is getting. Arjun, please turn on camera. Getting.
Yes, sir. 1 minute.
Known. And what about CPT2? किया आपने CPT2?
Sir, not fully. I finished a little.
Why little? था तो था ही नहीं. And Chinmay, why are you not coming here nowadays for practice and all?
So only for a short while. I'll start coming from tomorrow. Don't worry.
Okay. Okay. Fine. And आप लोग को भी रुकना है थोड़ा सा writing practice बढ़ानी है आप लोगों की. Discussion हुई है कई बार. अभी exam चल रहा है.
No, it's got only I will start from
Yeah. See, you have to start and discuss with me. Is given, and you are using 0 ml of NaOH, 10 ml of NaOH, 20 ml, 50 ml, 80 ml, 90 ml, 99 ml, 100 ml, 101 ml. What will be the change or what is the pH value of the solution? How will you solve? Let's see one by one all the cases. So what is pH? pH value is defined as, Shravi, what is pH? Minus of H plus. Simple सा formula होता है. Look, लिख लीजिए. Minus of log of H plus is pH. Okay. Try to understand and catch up, right? Everything. So if you have 0 ml of NaOH, what do we have? We have just HCl and that 2.1 molar HCl. Okay, and 0 ml of NaOH. So case number 1 को solve करते हैं पहले. Case number 1. What will be H plus concentration in the solution? Everybody, how much is H plus concentration? You will say 0.1 molar HCl. 100 ml is given. You are adding 0 ml. So what's my answer? 0.1 into 100 divided by 100 plus 0. ये तो 100 ही रहा. So can I say answer is 0.1 only? Okay. कितने लोगों को समझ में आया कि मैं सीधे 0.1 पे लिख सकता था? Right? If H plus is 0.1, mathematically what is log of 0.1 with a minus sign? Log of 0.1 is log of 1 by 10. Log 1 minus log 10 is minus 1. तो ये वैल्यू कितनी हो जाएगी आपकी? 1. लिख लीजिए 1. So when you have 0 ml NaOH, the pH value starts at 1. कर लेंगे? इसमें कोई problem? Any issues in this? Next 10 ml पे क्या होगा? When you have 10 ml, what will happen now? Tell me please. How many MEQs of HCl are given? You'll say MEQs of HCl are 0.1 and 100, right? Okay. How many MEQs of NaOH will be there? 0.1 into 10. Remember, its N factor is 1 and its N factor is also 1. Niharika, is it clear?
Yes, sir.
Okay. Volume into molarity into N factor equals. अक्षय नहीं है. एक बार चेक करिएगा रुपेश जी. नहीं आएगा. क्यों? घूमने गए? बाहर गए. Okay. Sanjana, what is this value? Volume into molarity into N factor. Molarity into N factor is normality. Normality into volume is gram equivalent. If it is in liters. If it is in ml, if V is in ml, then it is called milli equivalents, MEQs. Okay. So I repeat once again. Molarity into N factor is called normality. Moles into N factor is called gram equivalent. Okay. ये फॉर्मूले पता है आपको? Moles into N factor is called gram equivalent. Millimoles, note down please, into n factor is called milli equivalents. दोनों तरफ divide कर दो volume से, तो ये moles upon volume क्या बनेगा? Molarity या नहीं क्या बनेगा? Normal. Easy. Any problem in this part? Any issues in this part? So what will be for 20 ml? Sorry, 10 ml. 10 ml, 100 into 0.1 is how much? 100 into 0.1 into 1. 100 into 0.1 into 1 is how much? 10. 10 milliequivalents of HCl. NaOH कितना आपके पास? 10 into 0.1 into 1. मैथ्स बताइए 10 into 0.1 into 1 कितना होता है? 1 MEQ. इसके 10 MEQs है, इसके 1 MEQs है, ये एसिड है, ये बेस है. 1 MEQ will react with how many MEQs? Only 1. So how much of H plus will remain? 9. तो कह रहे से H plus effectively will be 10 MEQs of H plus minus 1 MEQ because of this maths. I'm subtracting 1. Remaining MEQs of H plus divided by total volume. 100 and 10 ml iska. Volume will be added, no? See, volume cannot be subtracted. Volume will be always added. You understand this point? Any doubt in this? What will be the next one with this logic? 20 ml ke saath. Can you tell? Just tell, then write later. What will be the answer for next one? 10 minus divided by? Very good. ऐसे नेक्स्ट कर लेंगे फटाफट सारे करके आप इसकी वैल्यूज निकालते जाइए एवरीबॉडी डू या पीएच भी निकालेंगे पहले आप एच प्लस निकाल लो फटाफट तो 3 का पहले एच प्लस निकाल लो पहले एच प्लस कर लेते हैं फिर पीएच भी कर लेंगे 10 माइनस 2 अपॉन 120 इसके लिए 4 के लिए 10 माइनस 5 अपॉन 150 इसके लिए 10 माइनस 8 अपॉन 180 फॉर दिस वन 10 minus 9 divided by 190. For this one, 10 minus, what shall I write? 99. 10 minus 9.9 divided by 199. यहाँ पे आगे रुक जाओ. Any difficulty in this part? All of you are comfortable? Everybody, Arjun, Sanjana, Chinmay, Niharika, is it clear? Yes or no? Clear? H plus निकाल लेंगे. H plus आगे तो pH भी निकाल ही लोगे. थोड़ी मैथ्स लगानी पड़ेगी और क्या. So इसका वैल्यू कितना होगा? माइनस ऑफ लॉग ऑफ 9/110. चलिए लॉग टेबल का यूज करके बताइए लॉग 9/110 कितना होता है फॉर दिस यू कैन यूज कैलकुलेटर फॉर दिस पर्टिकुलर कैलकुलेशन टेल मी व्हाट इज द वैल्यू ओके जो सॉल्वेबल है वो कर लो 10 माइनस 2 अपॉन 120 इज व्हाट 8/120 8/120 कितना होता है भाई 15 टाइम्स सो दिस इज माइनस लॉग ऑफ ये तो कर सकते हैं सॉल्व 1.087 ठीक है अच्छा इसका कितना आंसर आ रहा है हाँ 1/15 we can solve also no 2/30 so 2/30 1.17 next please solve quickly give me the numbers for all these four क्या तो समझ में आया so what are you trying to do we are trying to neutralize H plus right what are the numbers 10 minus 5/150 is 5/150 is 1/30 1/30 is how much it will be 1.47 71 next is 2/180 2/180 is 1/90 1/90 will come 1.9542 कितने आ रहा है 10 minus 9 1/190 1/190 19 का निकालना पड़ेगा कितना 2.27 नेक्स्ट वन 99 के लिए बता दीजिए थ्री पॉइंट टू हाँ मैं 3.29 ठीक है, प्लीज नोट कर लीजिए सारे वैल्यूज. आई होप दिस कैलकुलेशन इज maybe calculation is difficult, but if log is good, you can always solve. Please note down. Sanjana, Niharika, Chinmay, Arjun, is it clear? Comfortable up to this? Now, please do one more small task here. What about 100 ml? यहाँ पे क्या हो? At 100 ml, this and this will exactly match. They will neutralize each other completely, and this H plus will come 0 in a way. 10 minus 10 हो जाएगा. तो pH कितना होगा इसका? 7. How many of you realize that yes, if we try to do this and try to plot a graph, I'm trying to plot it here. pH versus volume of sodium hydroxide. This graph starts somewhere around 1. ओके, यहां से कुछ शुरू होगा वैल्यू कितने ml पे? 0 ml पे. तो यहां से आप 0 पे तो कुछ है ही नहीं वैल्यू. 10 ml. ओके, 10 पे वैल्यू कितनी है आपकी? 1.08. ठीक है, तो ग्राफ एक मॉडेस्ट सा ग्राफ ऐसे इंक्रीज होता हुआ जा रहा है. देखो, ये सब करते करते आप 3.29 पे पहुंचे थे. 3.29, you were somewhere at 100 ml. So let's say this is 3.29 and this is 100 ml. What happened suddenly? 100 ml, as soon as I mixed next 1 ml, the value jumped from where to where? अगला जो 1 ml आपने ड्रॉप किया यहां से 101 करते वैल्यू शूट कर गई. Can you see the steep change? Because you were here 1 ml back and 1 ml after you were here. How many of you understand this line? Online student, is it clear? Can I say there is a sharp increase in just 1 ml? Don't you think it is a difficult titration or easy titration to do? It's very difficult titration. What will happen? When you start doing titration, you will start from here. 10, 20 मिलाते जा रहे हो, कोई color change नहीं हो रहा है. You'll be complacent after this. 90, 99 पे रहे, चलो कुछ हो ही नहीं रहा है तो मिलाते जाओ. Suddenly you'll mix, it will become 7 plus. 3 से 7, अब बीच में खो गया. Then you try to reiterate, try to get it, which will be very complex. Because in just 1 ml, it's a shoot up kind of situation. Can you observe this point? Hence, this titration is a complex titration. And it needs very good identity, like what you call, indicator. So that it can indicate where exactly titration is complete. Is it clear? What will happen after 101 ml? Can you guess? Anybody can guess? What will be pH value after 101 ml? So OH minus will dominate now because OH minus 101 ml मिलाओगे तो OH कितना हो जाएगा? 10.01. So yeah, so 10.01 minus 10 divided by 210 ऐसा कुछ नंबर बन जाएगा. इसका एक बार log देके बताइए. This will be OH minus concentration. इसका pH कितना आएगा? Anyone? So 7 is exactly at 100 and इस 100 से 101 इसके जस्ट पहले 99 पे आप यहाँ पे थे, 101 पे आप उधर पहुंच जाओ. Is that okay? So the graph is clear, and later this graph will go like this. Okay. So the nature of acid-base titration is this kind of graph. It start gradually, sudden shoot up, then gradually increased. Watch. कितनी वैल्यू आ रही है इसकी? 10.7. So can I say 7 से 3 ऊपर, 3 up from 7, and this is 7 से 3.5 down. So see, suddenly your values are shooting up with just 1 ml. A small mistake and we can end up from 3 point something to 10 point something. Those 2 mLs, okay, polio drop, 2 ml, इसमें ही यहाँ पे सारा change हो रहा है. Is it clear? Are you observing this whole process? Any questions? Is it clear, Shravan? Understood what whole detail? Great. So this is acid-base titration that we have learned. Niharika, is that clear? Sanjana, Arjun, and Chinmay. Completely clear? Now please look at something. I'll just show you. Can I remove this? Have you written off? Okay. So just see this diagram. The same discussion that you're having right now. So this is how a strong acid versus strong base graph will take place. This small delta V, and you have sudden change from here to here. That makes this whole thing very, very complex. So pH is 1.07 for 10 ml, 50 ml. मैंने आपको 20, 30 भी करा दिया था, but I'm just showing you. For 50 it is 1.47. For 95 it is 2.5. For 100 it is 7. Okay. लिख चुके हो आप already. ठीक है? Is that okay? And then 101, when you solve, it is 10.7. Any difficulty in this? Any issues in this? Right on the heading, titration of strong base versus strong acid. That means you have to take strong base as a given thing and you are solving for strong acid. Can you predict the graph without even doing the question? Opposite of that. How opposite? Like reflection through x-axis, y-axis,
Reflection.
y-axis. Okay.
Take pH drop.
Good. Good, good, good. Please draw the graph. कितने लोगों को समझ में आ रहा है ये graph बनेगा? Correct? So last graph was like this. This graph is decreasing, sudden decrease, and then. Is it okay? This is the graph of pH where a strong acid is given to you and you are using strong base to titrate. Strong base you are adding from outside. Is that okay? Sorry, other way around. Strong acid you are adding from outside. So strong base, strong acid we are adding from outside. Is that okay? Strong base versus strong acid case. How many friends understood these two things properly? Raise your hand if it is clear. Pakka? Confirm? Very good. Sanjana, Arjun, Niharika. Confirm? Any issues? No issues. Great. Okay, let's progress further, proceed further. Now write on the heading, weak acid with strong base case. Weak acid versus strong base case. Case number 3. Case number 1 हो गया. Strong acid, strong base. Case number 2, strong base versus strong acid. Case number 3, weak acid versus strong base. So write on the heading, weak acid versus strong base. So let's write down. So for the data point of view, you take 0.1 molar acetic acid. 100 ml ले लीजिए. 0.1 molar acetic acid. And for titration, you can take strong base sodium hydroxide. You take 0.1 ml only, 0.1 molar only, 0.1 molar only. And I'll give you different values now for this. So interesting values will be, you can start with 0 ml. You can start with then 10 ml. You can do 25 ml, 50 ml, 75 ml. I'm doing it for a reason. 100 ml. 100 ml के बाद आप ले लो 125 ml, 150 ml, फिर 200 ml ले लेते. Try. What do you have to do? करना क्या है सर? वही करना जो लास्ट टाइम किया. क्या किया था लास्ट टाइम? We found pH. Okay. So this is the given thing. This is NaOH is used to titrate. Starting from 0 ml, you're just mixing and you're trying to observe the neutralization point. So mathematically speaking, this is a weak acid. Its Ka should be given. What is Ka? Dissociation constant of weak acid. इसका value है 10 power minus 5 into 1.8. Note down. Okay. Shravya, can you recall weak acid dissociation constant K? Have you heard of this term? these two, it will refuse. So there are many restrictions. Welcome everyone, welcome to your own channel. Greetings everyone, welcome to your own channel. So mono, di, tri, tetra is clear everyone? Welcome everyone to your own. You have to use this number we can write Na or N naught in place of this number, okay? You can see the number Na, N naught or capital N. That will also represent this number. Every time you will avoid writing this big number, fine? So this is the definition of mole, fine? The next thing which we discussed was certain questions on this. Questions I'll not take right now because this is already being done. So I'll discuss with Melinda and Shelly separately these questions in practice in detail, okay? Because others have done that, will waste of others' time. We talked about a concept of AMU. If you have a single atom, like 6C12, its mass is how much? 12 AMU, okay? Shelly, your classes currently will be 2 to 6 for physics, and I think your group is created already. Is it as a group created for you? Shelly's prep or something like that? Already group है इसका ना? So उसी group में आप teachers को add कर दीजिए इसके group में. 10th वाला इसका जो group होगा उसमें add कर दीजिए teachers को, आशीन सर को, मैं को और अंगद सर को, ठीक है? तो उसमें आप फिर सारी classes post करते जाइए. Single atom 6C12. This 12 is what? This is called mass number, and 12 AMU, atomic mass unit, will be the mass of it. Fine? Yes. Atomic number is first. 6 is atomic number. 12 is mass number. Okay? So just to give you an idea, see, whenever you write any element, there are two numbers, Z and A. Z is atomic number and A is atomic mass, you can say, or mass number. Okay? Fine? Now symbols are fixed, we can't change it. So let's say we write 6C12, the 6 is value of Z and this 12 is value of A. Is that okay? And this Z will be equal to number of electrons, this will also be equal to number of protons. A minus Z will be equal to number of neutrons. Protons plus neutrons, which is called nucleons, is Z plus A minus Z, which is A. It is called nucleons. So how many of you know from 10th standard knowledge these things? Raise a hand. ये पता है पहले से आपको, इसमें कुछ बहुत difficult नहीं है, right? Shelly, is it clear?
Yes, sir.
So quickly solve one question. 92 uranium 238. Find out EPN. Okay, find out EPN. Find out these values for 92 uranium 238. Quickly. Electron, protons and neutrons. कितने होंगे? So answer should be what? 92, 92 and 146. कर लोगे? Easy question. Now if I ask the same question for H2SO4, find out EPN. What's the answer? Hydrogen is given as 1H1, sulfur is 16, sulfur 32, oxygen is 8O16. Try. करिए, solve करिए. Melinda, is it clear? Now I'm asking for one molecule of H2SO4. What will be answered? So to solve this question, there is a simple approach that you need to follow. You please write it like this. Don't do verbally, don't do in shortcuts. There's a method for it. Write HSO, which are components of H2SO4. ये method आपको हमेशा use करना है. It looks like कि थोड़ा लंबा method लग रहा है, but it will save lot of time and it will also save you from mistakes. And this method is to be used for any question. Okay? So let's say today you are finding an easy question, you can think, अरे मेरे को आता है. But tomorrow you can get a difficult question. Again, this method will help you out. Shelly, is it clear? So first you write this kind of table. HSO. What are HSO? These are elements of H2SO4. Now we write 1H1, 1632, 8O16. What are these numbers? These numbers are Z and A values. Then what is Melinda? What is? It's Melinda, right? M-E-M-I. Okay, Melinda. So what is E for this case? And P and N? 1 minus 1, that is 0. Next case, 16, 16, 32 minus 16, 16. 8, 8, 16 minus 8, 8. But remember, you don't have just one hydrogen, you have two hydrogens, so multiply by 2. You have one sulfur multiplied by 1. You have 4 oxygen multiplied by 4. Multiply to karna padega because I'm not solving for HS, so I'm solving for H2SO4. Any difficulty in this part? Any issues? So what's the number? If you multiply 2, can I say this number is 2? अब ये number आप circle करके लिख लो. 0 into 2 is not 2, it's 0 only. 16, 16, 16. Final numbers encircle करो, mistakes नहीं होंगी. 32, 32, 32. आज आपका एक STP भी है. STP समझते हैं? Speed test paper.